Optima has a quilt shop where she sells many colorful quilt blocks for people who want to make their own quilts. She has quilt designs that are made so that they can be sized to fit any bed. She bases her designs on quilt squares that vary in size. So she calls the length for the basic side X, and the area for the basic side is X squared. In this way, she can customize the designs by making bigger squares or smaller squares, which we talked about before. So we have a length of X and a width of X. So the area, if you tell them the length or the width, is X times X, which is X squared. If Optima decides to add inches to the side of the square, what is the area of the square? So notice here is that base square. We don't know how long it is. It could be 12 inches, a yard, whatever. But then she adds 3 inches this way and 3 inches this way. If you wanted to say what is the area, well, the new length is X, because this is a length of X still, plus 3. And the new width is X plus 1, 2, 3. And since area is length times width, X plus 3, that's a length, times X plus 3 would give you X plus 3 squared. So that is the area of the new squared. So it says use the diagram and the equation, this one that we just figured out, to explain why the area of the quilt block is also equal to this. Well, we could do that 2 ways. One, we could multiply it out because X plus 3 squared means there's 2X plus 3's. So if you square it, that's X squared plus 3X plus 3X plus 9. And when you simplify it, the area is X squared plus 6X plus 9. Or you can just count the pieces. We have 1 big X squared, that's this right here. The X's are the rectangles. How many do we have? 1, 2, 3, 4, 5, 6 X's. And how many little squares of fabric? 1, 2, 3, 4, 5, 6, 7, 8, 9. And so that is why they can be written in either way. Customer service representatives at Optima's shop work with customer orders and write up the orders based on the area of the fabric needed for that order. As you can see from problem 2, there are 2 ways that customers can describe the area of the quilt. One way describes the length of the blocks. Okay, that's this way, X plus 3, and then we square it. The other one describes each of the areas of the 4 sections. That was this one. For each of the following quilt blocks, color the block area that matches the expression blue. Basically, we didn't want you to have to draw it. We just want you to shade it in. So we have a length of X plus 2 and a width of X plus 2. So my square would look like this. Technically, we don't need this part right here. So really it looks like that. Now that you've colored it, you want to write the equation. So if you think about it, well, we already said it has a length of X plus 2 and a width of X plus 2. So that would be X plus 2 squared, or we have 1X squared plus 4X's, 1, 2, 3, 4, okay, plus 4 of the little blocks right here. So you could write it that way as well. Now I had this on here, I was going to ask you to do it yourself. Go ahead and color in this one to make it match. And you can see here, this is how it would be written. And I want to even give you 2 more examples from previous problems. And often we call the numbers in front of x squared a, so that'd be an invisible 1, the numbers in front of xb, and the number here that's just by itself c. So this is 4 examples. Your job is to color in this picture to match. and then to look at it and see what pattern you notice. Go ahead and do that, pause the video. Okay, now that you've paused the video, what did you notice? I hope that you noticed that if you take 2 times the orange, 2 times 2, you'd get 4. Okay, so 2 times the orange is the pink. 2 times the orange is the pink. 2 times the orange gives you the pink, right? Because we had 2 of these, 2 of them on each part of the square. So 2 orange equals a pink, or vice versa. You could say half of the middle number, half of B, equals the orange. So I'm going to rewrite it this way. 1/2 of the pink, so 1/2 of B equals, and I shouldn't say, equals the orange. And we call that H, because we've talked about it before, that if you're looking at transformations, it is A times X minus H squared plus K. This is our H value. The other thing you can look at is the orange to the blue. If you took the orange value and squared it, 2 times 2, you would get the blue. 1 times 1 is 1. 3 times 3 is 9. And 5 times 5 is 25. So the orange value squared equals the blue, or you could say the square root of blue equals the orange. The square root of 25 equals 5. And otherwise, you could say that H, because this is really H squared equals C. Optima likes to have her little dog Clementine around the shop. One day the dog got a little hungry and started to chew up the orders. When Optima found the orders, one of them was so chewed up that there were only partial expressions for the area remaining. Help Optima by completing each of the following expressions for the area so that they describe a perfect square. Then write the 2 equivalent equations for the square. So basically, we're missing the C part. We're missing the little squares. If you wanted to think about it, we know we have the big X squared, and we have 4 more X's. Well, in order to write a square, you couldn't just put those 4 X's here, because now it doesn't look like a square. It looks like a rectangle. So we would have to put 2 of them here and 2 of them here. Right? And if you go back to it again, we have our square, our X's were the pink. Okay, and now we're trying to figure out the C, or the blue area. How many pieces would we need to complete the square? That's the part that the dog ate, like it chewed up the order and ate this missing part. Well, if you complete this picture, oh look, we need 4. Now, if you think about that mathematically, we already said this pink one, okay, can turn into the blue one. Well, let's think about it even more, okay? The blue one is the orange squared, and the orange is half of the pink. So if we took half of the pink, 4 divided by 2, we would get 2. Oh, that is our H, right? 2 and 2. That's how much was added to the base square. And then if we squared it, 2 squared, that is our C. That's how much it fills in. So that is the 4. So this original one becomes x squared plus 4x plus 4. And again, this would be that blue part, and this is that pink part. All right, I'm going to do one more of these. So this time we have an x squared plus 6x's, so I've split the x's in half, right? So we're going to take the middle number, the pink one, otherwise known as the b divided by 2, or 6 divided by 2, and that tells me we added 3 to each side. Excuse me. And now we want to square it. So turn that into a square. And how many pieces are there? 9. So now let's go back and look at it again. We had a side of x plus 1, 2, 3. That's what goes in there if we were looking at it as the lengths of the sides. And if we were just looking at the pieces, we have the x squared, one of them, plus 1, 2, 3, 4, 5, 6 x's, right, which we already had. And then what was the leftover part? 9 little leftover pieces in here. I'm going to have you do the remaining 2. Here's a picture for this one to help you out. And then I want to talk about it. What is the actual relationship between b and c? Again, that is if you have x squared, that's an invisible a in the front, or an invisible 1, plus bx, so the middle number, to the last number. And I've already hinted at it. It is half of the middle number squared equals c, or half of the pink number squared equals c. Will this strategy work if b is negative? Well, I don't know, so I made a negative 10. And let's try it. We could draw a picture here, and there's 2 ways to think of the picture. One is to say that you have your big X squared, and then you're subtracting 10 from each side and it's getting smaller. And you'd still end up with a picture. The other way to think about it is to say that you have your big X squared and you're adding negative 10. So you'd do 5 here and 5 here, and it would be negative. That makes sense in math, but not really in the real world. And we'll talk about that later in class. Want to throw that out there. But we want to see if this works. And I already had the answer in. Oops. But let's see. What do? We take half of the middle number. Okay. So half of the middle number. And that gives us negative 5. Okay, so that's why we would have 5 on one side and 5 on the other. And then we square it to get the 25. And what I wanted to show you here is this is the orange piece. So if you were to rewrite this one, you don't have to do this, but it'd be rewrite as x minus 5 squared. That's where the orange piece comes in. It's half of the middle. And why did it work? Well, even though we had a negative, when we squared it, a negative times a negative, it canceled out. Negative 5 times negative 5 made a positive 25, so it still worked. Lastly, will this strategy work if b is an odd number? Well, odd like 1, 3, 5, 7. Okay, what happens to it? Well, let's try it. We're going to take half of the middle number, which was half of the pink number. Half of 5 is 2.5. That's actually the orange number if we were going to rewrite it. That's the h, okay, the length of the picture. And I'll show you what that looks like right here, right? So we have our x squared, and then we have our x's. We had 5 x's, but we cut them in half, right? So that's 2.5, 2.5, 2.5. And then we squared it. Well, 2.5 times 2.5, if you put that in your calculator, you will get 6.25. So it worked. We finished the equation. What happens to c if b is odd? Well, then c is a decimal or fraction. And let's look at our picture and see how that works. Okay, we had our x squared, our basic spot right there. We again had the 5 x's. 1, 2, 3, 4, plus 2 halves, that makes 5. And then we need 6.25 of these squares. So let's think. 1, 2, 3, 4. Here's 2 halves, that's 5. Here's another 2 halves, that's 6. Oh, and we have our little quarter. So 6.25, it worked. Please fill this in and do any of the parts I didn't do and bring it in for points. Thank you.